of software development. And the third session, can you all hear me, colleagues?
Yes, sir, yes, but
yes,
you don't see your screen.
Okay, great stuff. Yeah, so I was saying that today's session is really primarily relating to the software development, and we'll focus on software principles. We're also going to touch on the cloud computing overview. Why? Because we will be deploying the application that we'll display today on the cloud environment. And then with that goes things relating to DevOps, development and operations principles. That is the second or the third thing that we will focus on. So today we are joined by the experts in the industry in the form of Mohaji Mababa and Tsepo Monama. Mohaji will start the session where we're going to talk about the software development principles, and I will touch or deploy the software application on cloud. And then the last session will be conducted by Tsepo Monama, where he will address the issue relating to DevOps principle. Without wasting any time, I'd like to welcome Mr. Mababa. He may introduce himself further so that we can really understand who he is before he can continue. Mohaji Mababa, over to you. Thank you.
All right, thank you very much. Good afternoon, ladies and gentlemen. As Mutlogo has already said, I'm Mohadi, and I'm currently a senior software developer for a private company in Pretoria. So, yeah, so today I would like for us to discuss just basic software development principles. Let me share my screen, Mutlogo, if I can.
Okay, yes.
Can you see my screen?
Yeah.
Okay. So can you see my slides there?
Yeah, clear.
All right, thank you very much. Yes, so today we're going to talk about just basic software design principles. And we're going to look at a few of them because there's quite many software design principles. So we're going to look at a few of them, and then hopefully after this session, you can be able to look back and maybe go and do further reading and research on other software development principles or design principles. And so today's session is actually very, very basic in terms of it is the introduction to these things, and we're not going to go into too much details, but there's going to be a demo at the end of the day, as Mutlogo has already alluded to, where we will have a simple web application developed using ASP.NET Core, Razor Pages, and this app will pull data out of a SQL database and display it on the screen. And this application will be deployed to the cloud, and the database will also be deployed to the cloud. But that is the second part with the demo. So perhaps I should start by just asking, I mean, you can just imagine how much software you've got in your room currently as we speak. I mean, in my room, I see I've got a laptop with a lot of software in it. I've got a computer screen, it's got a lot of software. I've got my phone, I've got the TV remote, I've got so many things that revolve around software. So software is at the center of our lives. I think if we were to switch off software tomorrow, our lives would be miserable, to say the least. So software is very, very important to every life that exists on Earth. And so, and when you think about software, it's not just about the software that you use on your laptop or on your phone. I mean, a basic thing like your car, I mean, a car has got so much software in it that even when you apply your car brakes, there is a software running to determine how much braking must happen and so on and so forth. So when you push on your car brakes, and there is some if-else statements that are being executed in your car computer box. And should that code fail somehow to execute or malfunction or anything of that sort, your car might not be able to stop. So it is important, therefore, to make sure that the software that we write is safe and can save lives and so on and so forth. I mean, we shouldn't be the ones writing stuff that will kill people on the road or maybe in the laboratory or everywhere else where the software is being used. So if you want to travel, you're going to need the software. I mean, for instance, using Uber, you're going to have to use software to book that Uber. I mean, to cook, your stove, your microwave, everything today is running some sort of a software. So now we want to talk about how to go about creating this software in a manner that is sustainable and that will make your software safer for people to use. And that if you need to change that software in future, maybe you want to add more features or something like that, then you will be able to do that without any adherences and something like that. So, I mean, on the agenda, we've got very basic stuff. First, we're going to talk about why do we develop software. There must be a reason why we go all out to say we're going to develop software. We're going to look at some code structuring, and not necessarily with examples, but more with just talking about basic things that you need to have in place in order to ensure that you've got a better code structure. And then we're going to talk about design principles, introduce the design principles, and finally we're going to do a simple demo. So now, as I've already said, I mean, why do we write software? I mean, a very simple thing is that we write software to solve a unique problem. And this is very important. So there's so many problems in the world, and many of them are already solved. So when you sit down and you want to write a software, you should make sure that the problem that you are writing is unique, so that the solution that you give is unique. And this uniqueness in this case, I just mean we should, in software development, we try and avoid reinventing a wheel. So we always look at the existing solutions. If they are there and we can tap into them, you go and tap into them. So software is written to solve problems. But is it enough just to say, I wrote a software, it works? You know, so, and this is where we say, you know what, it is not just about solving the problem. You need to solve it in the right way. And writing and solving it in the right way means the software will work today and it will work tomorrow. And this is where the principles comes in, whereby you start to say, how do I structure this code? How do I go about writing my code, and so on and so forth. So let's start off with code restructuring. So the first thing about code restructuring that you should ask is, why do people organize their things? I mean, you organize things because you want to be able to find them easily when you're looking for them. I mean, I can give a simple example with a dictionary. I mean, if you go into a dictionary looking for a word, you're more likely going to find that word simply because you know that dictionary is organized in an alphabetical manner. So if you're looking for the word that starts with S, you'll page to S and then start looking for the words that are next to the one that you're looking for, and eventually you'll be able to find your way. So when you write software, it is important to structure it in such a way that it will be easy for people to read. So your software should be readable. So the structuring of the code ensures that when people come into contact with your code, they can understand and be able to say, this is what you was trying to do. If they need to make a change, it will be easy to make that change. And this is where the maintainability thing comes in. Because you're not just writing software to run today and you're done. The software is going to run over a period of time. And over that period of time, there's going to be many, many requests. There's going to be requests to change the code. There's going to be requests to add more features. So you need your software or your code should be structured in such a way that when someone wants to make changes or want to add features, it will be easier for them to add those features. And this comes down to how you structure your code. And of course, this leads to correctness, because now if there's something wrong with your code, because you can read it and you can understand exactly what is the intention was, then you can correct whatever mistakes are there. So this then becomes a very, very important part of writing the code. And the other thing you must also realize is that a computer itself does not understand the code that you write. The computer understands zeros and ones, but we don't write our software in zeros and ones. So the question is, who are we writing the software for? Is it for the computer? No, because after writing the code, we use compilers and interpreters and everything to convert that code into zeros and ones. That means the code that we write is meant to be read by other coders or other software developers or in your team and so on and so, even yourself. I mean, you write the code today, tomorrow you need to come back and make changes, and you need to be able to be in a position to understand what this is all about. So it is important that you structure your code to improve readability, maintainability, and correctness. Now let's talk about conventions, because in order to achieve this structure, there must be some conventions and standards that you should be able to establish. And the question is, why are these things there? What are they doing and everything like that? So a coding standard is simply just a collection of rules and guidelines. So in a team, you sit down and you say, you know what, these are the way we're going to write the code. And these things, these are as basic things as how we're going to name our variables, how are we going to name our classes, where are we going to put certain part of the code. Let's say you say, okay, for the database code, you're going to put it in this module. For UI code, it's going to be in this module. For business logic code, it's going to be in this module. So you decide upfront what sort of conventions you're going to follow. And and what you need to do, you need to document those so that when a new member joins the team, you can refer them to that document that this is our coding standards. And why are these important? These coding standards are very important because you want to ensure that the code produced by different developers in the team is uniform. That when I look at the code that developer A wrote and developer B wrote, I can see that these guys are following the same standards, and there are no surprises when I look at the code. And the fact that there are no surprises will obviously improve the readability of the code, because I know that when I see something like this, it's because we're following the standards. Therefore, there are no surprises. So it is easier for others to look at the code and improve. I mean, they read it and they can then improve on the code if need be. And also, this will increase the efficiency, because now they don't have to spend a lot of time trying to understand why you name things the way you name them, because there is a convention that is agreed upon in the beginning. So it will also increase the efficiency, as well as helping with detection of errors in the code. Because if I see something that looks strange, that is not something that we are agreed upon or something that is a standard across our company, then I'll have a look, and then it might indicate that maybe there's a problem with that piece of code. So having coding standards and conventions helps with all those things. Where your code is uniform, it improves readability, it increases efficiency, and it can assist with error detections. And by the way, if there is any question, you should be able to ask as I go. And Mutlobe, I think you should be able to see. I don't know if I will see if people are raising their hands. But if there is any question, please just shout. So now let's talk about design principles, because we're saying you've got these conventions that you agreed upon, that this is how we're going to name our classes. This is how we're going to name our variables. This is how we're going to name our functions. This is how this is how big our classes are going to be. But you also need to say, what are the principles that you might follow? So principles are nothing more than just guidelines to say, you could structure your code in this way. This is the things that you could follow. And the aim at the end of the day is to try and produce what we call a clean code. And a clean code is nothing more than just the code that is maintainable, the code that executes and does what it's supposed to do, and the code that is easy to read. And that's what we mean by clean code. And that would be the aim of your principle. So I'm going to talk about the 4 principles. I mean, you've got the KEYS principle, which simply stands for keep it simple, stupid, meaning you need to, whatever you do, make sure that you keep it as simple as possible. And then we've got YAGNI, which stands for you ain't gonna need it. So this means when you write your software and there's something you want to write, but you know you don't need it today, maybe you're gonna need it in 6 months. You shouldn't write it because it's not yet needed. And you might find after 6 months, the requirement has changed, and that whatever you were thinking of writing back then is no longer required in 6 months. Therefore, wait until a feature is required before you put it into your code. Then we've got DRY, which stands for do not repeat yourself. I mean, this is very simple. When you write software, I mean, we said we don't want to reinvent the wheel, meaning, I mean, if you write a logic to calculate text, so that logic to calculate text for a given person should exist in one place in your code, because if you write that logic in 10 places, and then tomorrow your boss comes in, it's like, you know what, we actually want to change the way we calculate text. But see, you see now you've got a problem, because now you've got that logic in 10, 20 places. Now you need to find all those places and just to make a simple change of how you calculate text. So, and if you miss one of them, it means now your software no longer functions as intended. And then we've got solid principles. A solid is an acronym. And each one of the letters in that word is a principle by itself. So it's a very, very long topic that will need another separate session to talk about solid, but I'm just going to give you an overview of each one of those principles in the next few slides. And all these principles combined, if you follow them and you apply them in your code, you might have at the end of the day what we call a clean code. So they don't guarantee that you get a clean code, because you can still create a mess while following these principles, but at least they put you on a better footing. So you still have to be very, very careful how you write your code and so on and so forth. So let's talk about keys, or keep it simple, stupid. I mean, you can see here, I mean, we've got point A and point B. I need to reach point B from point A. How do I go there? I mean, someone can say, you know what, I don't care. So long as you find yourself at point B, that means you have successfully gotten there. But now with software, we say, no, wait a bit. It's not about the result. It's also about how you got there. I mean, here on the first, let me just get the laser. So here on the first one, you can see this guy has been going around tumbling and turning and doing all these unnecessary things. Whereas the second route here is straight from A to B. Now, let's imagine tomorrow they ask this guy here. They say, how did you get to point B? Can you produce the map for your route? I mean, I don't think this guy will be able to produce this map. And this is what we mean by complexity and readability. You can see that this is so complex that it is difficult to reproduce or to read or to look at and say, this is the route that I followed. But for this guy here, I mean, it's straightforward. It's just that I walked very straight from A to B, maybe going north. And if you want to go to B, you just need to start at A, go north straight, and then you get to B. But this guy, this is what we mean by keeping it simple. So you need to follow the simplest thing that is available. And there is a code that says, perfection is not reached when there's nothing left to add, but it is when there's nothing left to take away. So you try and simplify as much as you can. And as soon as you realize there's no more simplification that you can do, that means now you have arrived at the perfect solution for the problem, or code for whatever you're coding. So this is very important in software. When you write your code, always keep it simple. Don't overcomplicate, overthink the solution. If they ask you, write a code that will return, let's say it's a calculator. Let's say if I give this calculator 0, it must return 0, because it's gonna say 0 plus 0 is 0. I'm just giving a simple example. So At that point, the only requirement you've got is about 0. So don't go and start figuring out how to add, how to multiply, how to divide, how to do square root. They just ask you for a very simple thing, return 0. Just write a simple method and return 0. Tomorrow they ask for something else, then you extend that code to do what they are asking for. So you always do the simplest thing to get the solution for the problem. We talked about the YADMI. I think I've already went through it. I mean, this is an extreme programming principle that says features should only be added when they are required. So you shouldn't add anything that is not required yet, because the chances are you might not need it in future. Hence, they called it, you aren't gonna need it. So this is a very basic thing. I mean, and this does not relate to how you write code, but it relates to the decisions you make about writing code. Because now, if I'm writing a simple web application, and I suspect that I'm going to need a SQL server to store the data, but that is not needed yet, they said, no, you can defer that until 12 months later. First start off with doing your business logic and the UI. If I go ahead and start designing a database based on the fact that I think I'm going to need SQL, and 12 months later, I realize that actually I'm going to use maybe a NoSQL database. Now I've done so much work to speak to SQL Server, but I'm not gonna need all that. So you only put stuff that you need at that time when you're developing the software. Don't put anything else. And this, I mean, obviously this goes back to keeping it simple. You do exactly what is enough to get to the solution. Okay, let's see. Now let's look at dry. Don't repeat yourself. So the idea behind this principle is that repeating yourself is a bad thing when writing code, because like we talked about earlier, because now you've got a logic in 2 different places or 10 different places. If you want to change it, then you need to visit all those places. And it's not only visiting them, you also need to remember about all of them. Because if you, like I said earlier, if you forget one of them, that means now your software no longer behaves in the way that you intended it to behave, because in one area, you're still using the old way of maybe calculating an insurance premium, and you've since changed in other places. So if you've got that calculation in one place, it becomes easier, you go and change it. I mean, I remember, I think, was it 2 years ago when they changed VAT from 14% to 15%. There was a lot of jokes on the internet about how people now they need to search for 14 in their code. Because you can imagine how difficult it would have been. I mean, let's say you would just say, you know what, the VAT rate is 14%, and you go and use 14 all over your code. Now it changed to 15. What do? You need to search for 14 in your code. And if you're lucky, you're going to find all of them, but you could have avoided it by just having it as a constant in one place. And when you need to change it, you change it in that one place. So this is very important. You do not have to repeat yourself. And here, you must be careful, because here we're talking about a duplication of the logic. Because some things you will repeat, because code is code. So, I mean, if I'm saying string name, let's say that's my variable. I mean, I'll have another string name somewhere else, and that string name could mean something else, not necessarily the string name that I'm working with currently on the other part of the code. But when we say don't duplicate, we mean don't duplicate logic. So there's a certain way you do certain things. Let's say calculating the premium for the insurance. I mean, if you duplicate that is logic, and it is very central to the application, probably if you're writing an application for the insurance company. And it also speaks to the whole idea of do not reinvent the wheel. I mean, the wheel is already there. It works very well. Everyone uses it. So instead of spending years and hours trying to reinvent the same wheel, you just pick the wheel and you use it. So this will encourage you to then start the code reusability. So you write your code in such a way that then you can reuse it in other parts of your application. Mutloga, I hope I'm not moving too fast. and we already talked about this. I mean, this, don't repeat yourself. This principle promote code reuse, obviously, because I need to put this logic here. I need to reuse it in maybe 100 more places. So now let's talk about solid principles. Like I said, this is a very, very big topic. And I mean, there's no way I can speak about solid principle in like 10 minutes. You need maybe an hour. And actually, it is even much more easier if you are demonstrating them in your code. So I'm just going to introduce them and then then later on, I mean, you can go ahead and maybe look at what they are, how they are used, how I can apply them in my environment, and so on and so forth. But this SOLID, like I said, is an acronym. S in this SOLID stand for Single Responsibility Principle. And single responsibility principle states that a class or a method or a module should have one reason to change. And another way to phrase it, you could say it should be responsible to do only one thing. So if you've got a class, let's say your class is you are saving data to a database. And in the same class, maybe you are sending an email and you instantiate the email, you set up the message for the email, and then you send that email. You can now see that your class is doing two different things, meaning, and it's going to change for two different reasons. Because tomorrow, if you change the way you save your data to the database, that class is going to change. And then if you change, let's say you change the way you send your emails, or you introduce now you're no longer sending emails, you want to send SMSs as well. Then your class is changing for a very completely different reason. Hence, they say a class should have only one reason to change. And this speaks to keeping it simple, because all these principles, they build on top of each other. So if your class is very simple, following the keep it simple principle, it means it is likely going to do exactly one thing, and it's going to have exactly one reason to change. But as soon as your class is too long, it's got so many things, it's too complex, then that means your class is probably doing more than what it should be doing. And normally when you see that, then the best thing to do is to refactor into maybe 2 more classes, or how many ever classes you would need to refactor it, so that your classes are very focused. They only change when they need to change for the right reason. And the O in SOLID stands for open closed principle. You see, now you've got your class that is doing one thing and is only having one reason to change. But now open closed is building on top of that, and it says this class should actually be closed for changes. You should not be allowed to change anything in that class. If you want to add more functionality to the class, you must be able to extend the class instead of changing it. This is where you talk about inheritance, polymorphism, and stuff like those, where you can inherit the original class, maybe override one of the functions, or extend one of the functions to do a little bit more than what the original class was doing. I mean, a simple example is, I just talked about sending a message. Let's say after saving data to the database, somehow you want to send a message, and in the beginning they ask you, you're going to send an email. But later on, they say, you know what, we also want to support, there are some people who don't have email addresses, but they gave us their cell phone numbers. So we want to be able to send SMS to those cell phone numbers. Now you need to have, a quick data way to do it. You have an if statement to say, if SMS, then if cell phone number, then send SMS. If email, then send an email. But later on, they come and say, no, actually, sometimes we just want to notify them inside the app. We don't want to send anything. Maybe they opted out of receiving those SMSs. Then you add another if. Can you see now, just to cater for the third requirement, you need to go back and change your class. And by doing that, you are violating open closed principle. The best way would have been to create different classes that inherit from the same or implement the same interface. And then every time you need to do a new one, you just add a new class instead of changing the existing one. And the L stands for list of substitution principle. This is very simple. What it means is that when you've got classes that inherit from each other, so the derived class should be able to substitute the parent class or the superclass without experiencing any new failure. So if I was using the parent and now I'm using the child, I should be able to expect the same behavior in terms of exceptions that are thrown, how it handles the errors and everything. There shouldn't be any new failures that we introduce in the child class. This is to allow you to make sure that the code that used to work, that was using that parent, continues to work. And this is built on top of the open close principles. But if you're using languages like C# and Java, you know, most of the stuff that this scope is concerned about are already taken care of by the frameworks that you use or the language. But in other languages, maybe that is not the case, and you need to worry about the parameters that you pass in and so on, the return types and so on. And then the next, we've got an I, which stands for interfaith segregation principle. Meaning, when you define your interface, you should make them as small as possible. Meaning, you should not force the people who are using that interface to rely on the code or on the interface methods that they don't need. So you should make your interface as small as possible. They must be focused to whatever you're trying to achieve. Then this also speaks to single responsibility, because if your interface defines an API that is limited to a single responsibility, that means it's going to be small enough, and you shouldn't have problems with having convoluted interface that people start maybe even throwing exception in other methods that they don't want to implement. And then we've got the dependency invention principle. So this one is where it just says in your software, you've got high modules and you've got low-level modules. You've got high-level modules and you've got low-level modules. And what it says is that high-level modules should never depend on low-level modules. In fact, both of them should depend on abstractions, meaning you shouldn't have your business logic, which is your high-level module, depending on your database. So both of them should depend on something else, which is an abstraction. And in terms of C#, we could talk about an interface, that both of them should depend on an interface. But so this is a very, actually, this dependency invention principle is very, very important. And you're going to find that in many principles, software principles, this dependency invention principle is going to come up many, many times. And I'm just highlighting it in the next slide, what I mean by low-level and high-level modules. I mean, everyone, when we started learning software or how to write software, we are told that you must break your software into modules. You must have your UI module, you must have your business logic module, you must have your data access module. And you can see this is without dependency invention. So here what I have is that the business logic here is directly dependent on the database. Maybe let me get the pen here quickly. So you've got this here, which is directly dependent on the database, meaning it cannot exist without the database because it is dependent in the source code. So the business logic is referencing the database. And during runtime, the same direction applies. So during runtime, this business logic is going to call into the database to get some data. So you can see the two arrows are pointing in the same direction. And this is bad for software development because the database, and why it is bad is because the database is deemed as a detail. Because like I said earlier on, you could switch from SQL to NoSQL, you could switch to a file system, you could save your data in blob storage in the cloud. There's so many ways to store data these days. So the database should never be at the center of your system. It should be a detail, it should be a plug-in, something you can plug in. But with this architecture, it is not a plug-in, it's actually the central because the arrows are pointing towards it. So this is without dependency invention. And the reason I'm emphasizing on this one is because this is a very, very important principle in software. So now let's look at the same thing with the dependencies. We still got the same, we got the business logic and we've got the database here. But now look at the direction. So now this is a high level module, by the way. So you can see this one, let's go to the left quickly. This one is breaking the dependency invention, but the dependency invention says this high module here, high level module should not depend on this low level module. It says both of them should actually depend on something else called abstractions. And this is what is happening here. You see now the business logic no longer depends on the low level module, which is the SQL database. In fact, it depends on what we call an interface in C#. And this is an abstraction. Therefore, now, and remember the principle says the low-level module should also depend on the abstraction. So this one also, all it does, it implements the interface. And during this is the source file dependency. So the direction now you can see turned, it went the other way. But during runtime, you still have the same direction. So this will always call into that during runtime. So now you can see the direction is different. So this is what we call inversion. We have inverted the flow of dependency. So during source file, we're going the other way around, but during the runtime, we're going the direction that we want, because obviously the business logic should always call into the database to retrieve or save data, but it shouldn't depend on. So if tomorrow I want to add another, let's say I was using SQL, tomorrow I want to use MySQL. So I'll add another module here for MySQL. And this module, all it has to do is to implement this database, or I mean this interface. And tomorrow I say I want to use a file system. Maybe I want to use maybe a cloud blob storage to store something else in my database. Then all I have to do is then implement that repository or that interface. So now the business logic no longer changes. All it does, it says, okay, I'm just expecting an interface. It doesn't matter who is implementing it. And this is very, very important when you design or write your code. You should always make sure that at the center of your application is the business logic. Everything else, like the database, the web, or the UI, and all the other services that are not at the center should be plugins. You know, the email service should be a plugin, a database, the web, and everything else. But your business logic should be at the center of how you structure your code. And this is very, very important, because tomorrow, you know, your business logic, the business logic, the reason we call it high-level module is because it's a very stable module. It doesn't change a lot. But I mean, with UI, there's always a new UI framework every day, every week, and so on and so forth. Okay, so let's see. And then we get to a demo. And this is where I'm going to speak about the app that we've developed. So I wasn't gonna sit here and start developing an app from scratch. So what I did, I wrote a simple app. It's nothing fancy. Like I said, it's just got one page, and this page pulls data from the database, and then it displays that data on the page. But the important thing to look into that app is just the structure of the code, and also how the projects are structured, and also because we're going to take that app and publish it to the cloud. And I think Motoko is going to assist with that. So as I said earlier on, everything that we discussed up to this far, you should take it as a suggestion or a guideline. So these principles are not silver bullet. So what you do with them, they assist you, but you should use them in conjunction with whatever you are trying to achieve in your environment. They must fit your environment, or your environment must fit them. You shouldn't code yourself into a corner because you say, no, I want to follow single responsibility principle, because you might be stagnant the whole year trying to achieve single responsibility. Maybe it's not achievable in the way that you are working, or the environment that you are in. So you should take these things as guidelines. And I would say, let's keep coding. So I'm going to look at the, I'm going to exit from the slides and look at the, what do you call it? And look at the code. So in the code, I used there's this thing called clean architecture. And clean architecture is nothing more than just a combination of many principles, some of them that we discussed today, some of them we haven't discussed today. But what it does, and this was actually coined by Robert Martins, and he took all these principles, he put them together, and he said, oh, but this could be a very clean architecture. So you can see the arrows here. The arrows here point at the direction of dependencies. That means at the core, you've got this yellow cycle here. This is your enterprise-wide business rules. That means this is your domain. So this is where you define your domain entities, you define the domain business rules and so on and so forth. And this domain module is not dependent on anything outside it. It is only, it is a simple, clean business rules or entities that you need to define for your application. They can be used, and they call them enterprise business rules because they are not. They might apply outside the application that you are writing. They might apply to other applications in your enterprise. Then we've got the use cases, which is the red cycle. The use cases, they are only allowed to speak to the entities or reference the entities, but they are not allowed to reference the DB and the web and everything else. So in your use cases, this is where you define the interfaces for your repositories to say, I want to speak to the database, but I don't want to directly reference a database. So I'm going to reference an interface. So that interface get defined in here in your use cases. Then you write your business rules like creating a new employee if your system requires that, and then retrieving employees and doing all these sort of things. But we'll see it now quickly with the demo. I think this is the end of the slides. Unless if there is any question, I'll move to the demo.
None at the moment.
All right, thank you, Mutokwe. Yeah, so like I said, let me just see, can I exit here? I hope I can. Yes, okay. So I'm going to bring another window here.
Yeah, there is a question.
Okay.
So there's a question here from TT. I also find it difficult to understand what is the runtime.
Oh, okay. So because remember when you write software, let me just bring my this window here. You see, this is the software that I wrote. So when I talk about we've got two. When you are writing your software, like let's say I'm here, I'm busy, I'm adding classes, I'm adding functions, I do all these things. This is called development. So that means during this time you are developing your software, and then you click on run. So when you click on run, then your software then get compiled and it start running. And that's what we mean by runtime. That means when your software is being used, it's being executed, maybe it's deployed, someone else is using it. I mean, when you talk about, let's say, an Uber app, so that app, while we're using it, that is what we mean by runtime. The software is live, is working, is being used. So that is what is meant by runtime. But there is obviously, I'm oversimplifying it. There is probably a better way to put it, but just to simplify it, it just means when you are using your app. So when let me go back to that slide that was talking about the runtime. I need to get there quickly if I can. I think it was this slide here. So it was on this slide where I was talking about runtime. So what I meant is that during development, when you are deploying, that means in your code, this module here, which is your database layer, is referencing this module. So this is the direction of the references in your source file. When you look at the code, you can physically see that this module here is actually is referencing that module. But when you deploy your app, because now you are inventing your dependencies. Now, during the runtime, we know that, oh, sorry. Did I just lose that here? During runtime, we know that this business logic needs to fetch data from your database. That means during the runtime, this module here is now pointing towards this module, or it's referencing this module. But the important thing is that so long as it's not dependent on it in source, that means it makes it easier and flexible to change and to switch things in and out. Like I said, I can add another source code here for another that implement that database. Tomorrow someone else says, no, I don't like that one. I want another one, so on. So because this one is not going to change because it doesn't depend on all these details here or the concrete implementations. And that's what I meant, basically.
Yeah, there is a follow-up to saying that, so the concept of runtime does not exist while you're still coding your program.
I mean, I would say yes or no, because while I'm still code, like as I'm looking at this code now, this is not running. Therefore, there's no runtime. But as soon as I run this code, I come here and say, okay, I want to execute this code. Even though I'm still running on my machine, it's still during development. Because remember, during development, you can run your code on your development machine. You can run your software there. And we call it running in a development environment. So even then, it is still running. So runtime just means during the time where you're executing your software, you're using it. It could be on your machine during development, but you are running it. But while you are writing your source code, that is not runtime. They call it, that is just, I mean, you're just still creating the software. But yes, you can't just say it doesn't exist during, so because now I can run this code to test it. Because remember, I still need to test this code. If I can run it here, it should still work. I mean, if I run it as an example, hoping that it works. Because when you're doing demos, there's always surprises. So it is building here, build succeeded. It's gonna start in a browser. Starting there. You see, now this is runtime now, but it is on my development machine. I'm just running it here and I'm just testing. So this is what the app does. It's a very simple app, like I said. It just says welcome to bootcamp with Mutloko, and then it fetches data from the database and then it displays that data here. So now what we want to take this app, because currently it's running on my machine. You can see it's running against this database here. If I change this and add another row here and I say 2022 as an example, I don't know, maybe on that day, or maybe something as a test again. Yeah. If I did this and I refresh my app, you can see it's pulling that data from that database there. But now we want to deploy this to cloud so that it will run inside the cloud, that anyone with the internet can use it. I mean, you will see, yeah, this is local. It's running on my machine. So anyone with the internet can use the app, and the database will also be hosted in the cloud. And this is where Mutloko is going to assist me with the cloud infrastructure so that I can then publish this app to the cloud. So see, the time is almost 4. Okay, let me run quickly to the app. Close this. So you'd remember, how do I hide this? I don't know. Yeah, there it is. So you remember when I talked about clean architecture, we talked about dividing your code or your solution into various components. You had a domain component or module, you had your application, and you had your data and the UI. This is exactly what I have. At the bottom, I've got the domain. What the domain defines is very simple. And the important thing with the domain is that it's not dependent on anything. If you go to dependencies, you can see it's only using the framework, which is the .NET framework. So it's not using anything other than that. And this is very important because you don't want this depending on other projects. You don't want it depending on a lot of external things. You want it to depend on only stuff that comes with the environment that you're developing in. In this case, I'm developing with .NET Core, so therefore it is dependent on the .NET Core. So in here, I define a simple model for for course. It's got an ID, a title, and a date, and a presenter, which is just a simple. So remember, this is a naive thing. I didn't want to make this thing too complex. Normally in normal circumstances, this will be maybe a person type instead of a string, but I just wanted to keep it very, very simple. But I also know that I need to be able to save this in the database, but I don't want anything here reference in the database. So instead of reference in the database, here what I'm doing, I'm defining a repository, which is the interface. So this interface is the one that is going to help me do that dependency invention. Then this is just a simple interface, which one method that says get courses, which is going to retrieve every course in the database. This is the domain. Then in the application, again, here I've got a very simple thing. I've got an interface for the service. And the reason I add the interface for the service is because I've got this service that retrieves, that says get courses. And the difference between these two, you can see this one returns a list of courses, and this one returns a list of, in fact, it returns a course view model. So I'm defining another model here for the view model that I'm going to use for this service to return. So, and the reason I use the interface is so that if tomorrow I want to define this service differently, maybe I want to, I don't know, maybe for some reason I want to use it in a different project or something, then I can just implement this interface. I don't have to worry about the concrete implementation. And therefore, whoever is using this service does not actually rely on this, but this is a concrete type. So whoever is using this service is going to rely on the interface. The same applies to this service. This service is reliant on the repository. And this is the repository is the one that fetches data from the database. So instead of relying on the implementation, the SQL implementation of that repository, I'm actually here relying on the interface. Meaning later on, I can switch this in and out by maybe introducing a new concrete implementation, maybe to use something else like maybe NoSQL or blob storage or whatever. Then you've got your infrastructure. The infrastructure is actually, in this case, is the database. So in my database here, you can see this is where I'm implementing that repository here. So this is the, guys, I hope I'm not moving too fast. I'm just looking at time here. So this interface here, now, this class is implementing that interface, and it says, okay, for this implementation, I'm going to use this DB context. And this DB context you will see now is using what we call entity framework. And this is, in this case, is EF Core 5. So then you've got that that thing there, that context there using entity framework. And then, so, and for those who might ask, what is entity framework? Entity framework is a object relational mapper that helps you to interact with the database without writing SQL. So you'll see in this code, in my code, I don't have any SQL code, but my app is speaking to a database. So entity framework takes care of that part. So it works very well when you've got a simple applications. I think even there are some enterprise applications that are so complex, but they still rely on entity framework. So that is the infrastructure or the database layer. I'm not going to talk about migrations. These are some EF core stuff. So you need, if you don't know what they are, I think you probably just need to read a little bit about entity framework. But these are very simple to understand as soon as you understand what entity framework does and how it works and what it is trying to do. Then I've got this small project here that I called IOC. IOC in this case stands for inversion of control. This is why I implement my dependency inversion. So this is why I tell the application which services to use. For instance, here, I'm saying the application, whenever it needs to use the core service, it must go and instantiate the core service concrete cloud. The same applies to the repository, that it must go and implement that sequence repository that I've got there. And then here I'm just migrating my database so that it can get initiated. So here it was an example that I wanted to do with the email, but the time did not allow. Then my UI is extremely straightforward. So I've got a simple page here. I'm just gonna look at that page. So in this page, you can see here, this is a very simple page. What it does, it relies on this. You can see the reference is the interface, and it uses that interface to get the data. And then when it's got the data, then on the front end, it just displays that in a table, as simple as that. You can separate that table there with the headers there, as simple as that. So I want to hand over to Mutogwe to do the what you call the cloud implementation, so that we can deploy this to cloud. Mutogwe, over to you, sir.
Okay, thank you very much. I think mine is not. It's a simple one. It's just to really demonstrate how can we implement the application on the cloud. So I'm just having one slide here, colleagues will bear with me. But I just want us to have understanding of why cloud, right? So I think he mentioned there about he's running his application on his local machine, but the cloud is giving us agility, as you see here. I think this is one of the things that we're going to see. Provides faster provision, and then other important things, the issue around the mobility. So people are using cloud, the modernization, and of course, to innovate. So what we intend to do in this case is that this is our architecture that we have, right? So Mababa is having application here, but in our case, what we're going to do is we're going to deploy this app services on the cloud and also databases. And then these are the steps that I'm going to follow. Firstly, create both these two environments, and Mababa will come and push that application that he was just showing you in here so that your colleagues can be able to access it there. So that's really the simplest thing that I'm going to do from my side. Because of time, so this is the environment that we are going to use. We're going to, in our case, we're going to use Azure I'll try to do this so that colleagues maybe can be able to see, yeah. So, and one other thing is, I'll try to do this. Yeah, so in our case, with this environment, with this cloud, Microsoft Azure, we are having different services, right? So if you're going to say services, you'll see it's going to list all the services that are there. So in cloud, we have something called infrastructure as a service, platform as a service, and software as a service. And then if you can see here, majority of the application here are more application and infrastructure and platform, right? So in our case, we are going to deploy the web service, right? So we'll click on the web and then we go to app services. I'm going to explain some of these things when I proceed. So now in here, because we do not have an app, we just need to go and say create. You will see, so you will see that faster provision, right? So in this case now, we need to create this web application, right? So on Azure, we have something called subscription. Everyone needs to have a subscription. All the resources in Azure subscription are built together. So Azure will bill you based on this subscription. So in my case, I'm using the student account, and that's why I say Azure for the students. And then other thing is what you need to do is every resource on a cloud belongs to the resource group, right? So this also is just to logically, put your applications together. right? So in my case, I created a resource group called Bootcamp. Now, other thing is we just need to give our app the name. So other important thing here is that because we are going to deploy the code, there are two things here. How are you going to publish it? Are you going to publish as a code or as a Docker container? So I wanted to check from your end, what will you put it here? Are we going to push this one as a what? As a code or a Docker container?
Now in this case, it would be code.
Yeah. So then if it's a code, we're going to choose a code here, and then the next one here, we're going to say runtime stack. Because it's a code, is going to ask you which framework are you going to use to deploy your application, right? So in our case, which one based on your application, Mababa?
.NET 5.
Yeah, so you can see here we're having most of this in Python, you know, and Java and the like. So in our case, this is what we are going to use. And then other important thing is which operating system are you going to use to deploy this? I think that is still a question maybe also to you, Mababa.
Yes, in this case, I think Windows will be fine.
Right. So then other thing, beauty part around cloud is that it's going to ask you about the region. Where do you want to deploy this application, right? So it's having different regions here. And then I think the beauty part is that, as you know, we're also having the region in South Africa. So in our case, we need to deploy this application closer to where it will be used, right? Because of the performance and latency and other matters, right? So in our case here, we're going to choose the region, South Africa, to say that it will be installed in the databases in South Africa. So this is just to give, when we create this web application, right, it's going to create two things: web service plan, and then even this web on it, itself, right? So here we are having different types of the plans. So we're having different types. This one is for dev and test, and then if you are going for production, you may choose this. The only difference here is really about the capacity, right? The capacity in terms of the storage and the RAM and the CPU. So in our case, in this case, we're going to just choose the simplest one, which is F1, which is just having 1 gig RAM and is run for 30 minutes. Of course, you can choose any, right? If you go to production, you'll see it's giving you different features, right? Auto scaling and daily backups and things like that. But in our case, we're going for the simplest one. That's what we're going to do. We apply it here, right? And we then proceed to the deployment, right? Some of this are important when we are maybe doing the production, but in our case, we are doing a simple thing, like this is just a demonstration. So we are not interested in this, the continuous deployment. Then we proceed also to the monitoring. We are not also interested, we don't want any insight around the application, how application run and things like that. We're not interested to take that. So I'm going to just disable this here. And then we are not going to use the text, but texts are also important in the environment where you are having different environment, maybe or different business units, right? You want to categorize your application based on your business units. Then you can put here departments and you say IT departments, finance and related things like that. But in our case here, this is not of interest for now. So that's where that fast provisioning comes in. I will create this environment, and then within 1 minute or so, it will be created, right? So we created this first part. The second part is for us to create the database. So it's the same thing, it's the easiest. You just come on your thing, you are looking for databases, which database you wanted to use. Previous session, we talked about this to say cloud can accommodate different databases, but in our case here, we are just looking for this SQL, Azure SQL server, right? So we don't have none at the moment. You just click a create. And in our case here, we are going for this, for the PaaS. We just want to create the PaaS one. Platform as a service, meaning that we are not interested in getting access to the server. We just want to consume the service, in this case, the database. You can see deployment of that is already done, right? Within a minute is done. So in our case, let's create this database. And then we're going to create a single database, right? So it's the same thing as I mentioned. This is important for every resource on the database. You need to have a subscription and then also resource group. Resource group, right? It's a bootcamp in this case. So we need to give our database the name. So we just say it's a bootcamp. Now, as much as we are not going to access this server, but you need to create the server where this database is going to reside, right? So this what I'm doing here. The same thing is going to ask you, where do you want this to be located? In our case, we need to be on the same region as our web application that we created, right? So it will be South Africa North. And the other thing is asking you, how are you going to access authentication? How are you going to authenticate to access your data, your database, right? So in this case, we're just going to create the username and also the password, right? That is that. So we're having different ways, right? But two ways actually. We can through SQL, and other one through Active Directory, Azure Active Directory. But in our case, we just want to go straight by passwords and username. So in this case here, we are creating this database where this server where our database will reside. So that is that, right? So we are done here. The server will be in South Africa. We are not interested in this elastic pool. Elastic pool is if maybe you want to create different databases that will going to share the same resources. But that's not what we're going to do. Other thing here is that I think that's where that flexibility thing comes in, right? It's asking you the resources, the type of resources that you are going to use, right? In our case, because this is just the demo, you can see here, if you believe you can see, look at this one. The first one is a general one, right? You see how much you can pay. This is $458 US. This is American dollar. So this is too expensive for us. What you need to do is you need to choose with this Azure. We're having two different ways of purchasing your resources, right? There's this one, so the visual core based, and then database transaction unit based. So in our case, because this is a simple one, we just want to choose the basic one. But of course, if you're going to run a huge database and all that, you have a flexibility to choose here. So just check the difference in terms of the price, right? So this one, because it's the basic one, it's going to cost around $7 per month, right? So and then this is applicable for us, and we're happy with this. We'll just select it, right? Other thing, one of the reasons about the benefits of cloud is about the reliability, right? So this talks about this here, right? This is about the backup storage redundancy. By default, if you are installing PaaS database as a service, it's going to have, this will be automatic, right? So it's just asking you to say, are you going? How are you going to get your backups? How will your backups be distributed, right? In our case, we're just saying, put it on a local, distributed within a data center, not across the data centers or even the region, right? And then this option is cheaper, because if you're going to cloud, you need to take cost also into consideration, right? In this case, now we talk about this is about the networking, right? How are we going to access our database? So our database, we're going to access it through internet. That's why here we are going to say public endpoint, right? If you are going to access it, there's something called if you're going to access it within your cloud environment, right? Within here, if you are going to access it here, we're not outside, you are going to choose this option of private endpoint. And the other thing is that if you are saying public, it's going to ask you here to say, what are you going to put as part of your firewalls, right? So in our firewall, so we are going to say, allow Azure services and resources to access this database, because that's what we are looking for, right? We need this app to have this access to here. That's why our option here will be yes, right? And another thing is, how are we going to access it? Who's going to access it? So this one is saying, add current client IP address to this. So this means my IP address, right? This means this fellow here. which is me now. Because this is what I'm doing now. So what it's going to do is it's going to add my IP address, right, on this database so that I can access it. These 2 points are important, but of course, you can still customize them even after you have created this database, right? So in this connection policy, in our case, we just take a default. And yeah, this one also encryption, because also encryption is is important thing that is happening on the with databases. We just take it default. Then we're also not interested in this Defender, Microsoft Defender SQL is also to do with the security. We're not interested in any of this for now, right? Then I'll just say hit next. Text also is the same thing. We're not going to do. And then we are going to say create, and then it will just give you the summary here, right, of the options that you have created. So that's what I'm going to do. I'm creating it here. Within 2 minutes or so, it will be created, right? So now it's showing, is coming, is created. So we created these 2 environments, right? But the key thing that we need to do is that we need to give this a connection string. We need to get a connection string from database here so that these 2 environments can able to talk to each other. Then thereafter, that's where I'm going to give this opportunity for him to, from his local machine to push that application on the here so that it can able to talk to each other, right? Yes, we're going to get the recording. I'm recording this. I understand I'm going bit fast, but that's what we will be doing. So I created this. You can see it took a second, right? And then now I'm creating this database also. And then if you are on what do you call our if you're on a normal data center, right? For you to come to that, to able to deploy this is a hassle because you will need to talk to the different people and things like that. But the beauty of with the cloud is giving you everything on the tip, right? So this is the environment that we have created. So while we are still waiting for, and then this is telling you, while we are still waiting for database to be created, right? I just want to go here so that I can explain a few important things. So as I mentioned, if you're creating web application, it's creating two aspects, right? The plan and then the actual app service, right? So on a plan, as you saw, we created what we call it the basic one, the free one, right? If you want to change it, maybe for whatever reason now, lots of people who subscribe to your web and whatnot, then you can come and increase it here, right? That's really the key important thing within here. So the actual one, the app one, that's where you need to check. There's still also a couple of things that you need to look at here. We're going to use this URL to access this application after Mababa has pushed those here. The other important thing is we are going to the configuration. I talked about giving the connection string. After this database, we can see, I think it's within 2 minutes, right? The whole database is done. What we need to do now is we must take the connection string of that database, and then we need to add it here. Why? Because we want these 2 environments to talk to each other, right? So I understand, I hope colleagues understand that. So if you go to all the resources that are currently created. If you can see here, there is an SQL server and then the database, right? So the key here, what we need to do is we need to ensure that, and then I've already done that. I think I explained it, right? We just need to ensure that we're able to access the database, this database, right? So this is my IP address, but I'm going to reboot my router now so that I can get the new IP address. So I don't have a problem with sharing it, right? So what we need to, what we do is, if you want to give someone access to this database, I'm going just to add their IP address here. This means that I'm the only one at the moment who can access the database, right? So, and then of course, I mentioned that other services, Azure services should be able to access this database. And then that's why here it's yes. So I think this is important thing that I want to Now, where do we get the connection string? Connection string, we get it on the database on itself. This SQL server, and then this is the database, right? Now, what you need to get here is this connection string. That's a very important one. Then we get this. This is our connection string that we need to do what? That we need to give it to our app server. Right? That's what we need to do here. So we'll, what is that configuration? Configuration here. You can see it's fairly, just think of those, the benefits that we talk about with cloud, right? We don't need to get, this is what I'm going to do. And then this will be, I'm going to avoid this thing here. And then our database is SQL server. This is my, but here, what did we use here?
So in this case, I used bootcamp
connection string.
Connection string.
Right. So this is where we are just telling you that I don't have to. I'm going to change the password, but I don't think it's important that I must disconnect or to stop sharing because but maybe for that reason, right? What I'm going to do now here is I'm going to get the password. I'm going to get the password, right? Maybe just for the good practice, I'm going to stop here so that I don't have to see my password. But that's what I'm just doing. I'm just doing here. Because remember, the password is a critical thing, right? So what I'm doing now is I'm just giving, because that connection string is the one that we are using to connect to that database. So we need to give a username and password as part of the things that are required for us to access the database. So that is that. I just come back and also still share. Now, what we did now is we gave this app access to the database, right? And then I think from here, and then I should able to give for him now to push this application to here, to this database. So I mean, to this app. We created this environment. So for example, in the work environment, right? Mababa will be then software people, and then myself, I'll be more from infrastructure engineer or cloud engineer. So I'm provisioning this environment to him. And then when everything is fine, he will just now show us how quickly he will push that application to this environment so that we can able to access it. So in a nutshell, what I've done is I've created this environment. I create this environment. I can make the connection between this environment. So what is required now is to push that software on his local machine to the cloud. And then from there, we're going to share the link for you colleagues, even wherever you are, so that you can able to access it. So that's really the purpose of this demonstration that I was doing. Baba, I think over to you.
So what name did you use for your database?
Okay, so
we just use bootcamp, if I'm not lying. I just want
yes.
To make sure. All right.
Yes.
All right. Okay. All right. Let me share my screen quickly.
Okay.
This is, doing demonstrations. It doesn't always go well. Hopefully it does this time.
Yeah. Let me mute myself here. Let me.
Okay, so here I want to publish this application now to the cloud. So, I mean, all I have to do is to right click on my UI application because this is the entry point to my application. So the entry point is my UI. So I right click on the UI and I say publish. So I'm just gonna start it from, from the beginning there. I'm gonna say add new. Then here it asks me, where do you want to publish to? And I say I want to publish to Azure. I hope that is what is called. And then, as you know, we global provisioned the Azure app service. using Windows. Hence here I'm going to select that. If you used Linux, I would select that. If you used the one with containers, I would select that. But in this case, it's straightforward. It's just Windows, and then I select that and I go forward. I mean, I've already logged into that account. You can see it's populating the stuff here. And so here I just need to select that app service. This is the app service that we just created earlier, just now. So I'm selecting that app and I'm saying finish. And this is going to try and set up the publishing. And now it's busy checking the dependencies. And now this is ready. You can see here, this publisher was able to see that my app is dependent on SQL database. But this is already, we already defined that the SQL database on our end in the infrastructure. So this is not an issue. So this dependency is made. And then now I'm ready to publish. Then I'm just gonna go and publish that app. So now you see in this window here, the bottom here is busy doing the build. Hopefully it will compile, it's compiling the code. It seems like it is done. Now it's publishing. It's publishing there, as you can see. So there it is, busy publishing my app. It's creating it's copying all the necessary files, all the DLLs that it needs. 18 more files. So this is where you just wait for it to complete. So you can see it is done publishing to Azure, and it tells me that it published to this URL here. So now it's installing that app. So now it published it, now it's installing the app on the other side. So it should install and restart the app. Now it did restart the app and it restarted successfully. So now that app is actually now deployed, and then it is actually opening that app for me, as you can see here. Oh, there you are. There is the app. Now we're live. You can see here. So the app is deployed and it's live. But unfortunately, there's no data because this is a new database that we just created now. We need to add some data, and we don't have a way to add from the front end. Maybe you can do it because you gave yourself access to the database. So maybe you can insert some records in the database there.
So yeah, then what I'll do is I'm just looking on that database. I think those who attended last week, they will fairly understand what we are doing here. What do I share or what?
No, I don't think it's necessary. Just maybe just add, and then you tell me to refresh.
Okay. Because I was hoping maybe other colleagues, they just want to get the feeling of how do we add.
Okay, I stopped sharing. Maybe you can.
Okay, let's see. So you created this.
Yeah, while you're busy, I just wanted to mention that now, I mean, when I deployed this, actually the entity framework, because that's what I'm using to communicate with my database. It created that table for me in that database that I connected to.
Yes, okay. So you create. Oh, sorry, I was saying. So this is our database, right?
Yeah.
Or our table now. So this is this, yeah. So I think what we need to do is, I have this thing here. You just need to insert this is title.
Yeah.
Title. I believe everything should be fine, right? So we just need to push our data in here. Let's see. What is our, what is your, oh, this is a courses, okay.
Yeah, the table name is courses.
Right, I believe everything should be fine. So we're just inserting the boom, voila, right? We can create, we inserted this, and then this is our. So what we need to do then is, and then I think, but we need to share this, the name. So we need to share, is this one, right? No, it's this one.
No.
Let's come here. So the idea is to, you can see there is some movement here. But I'm looking for the URL. Is this one?
Go to that last one, yeah, that one. Where would it be?
Okay, it's this one.
Okay, there you go.
So then I think even colleagues, I'll share on there. So then they will able to even access it here. So I'm sharing this on the chat. So they can also just access it from their side. They'll tell me if they can see it, right? Just use on the chat, just see if you can access this application that we just deployed now. I did share the thing. So as you can see, I created that database. I created it and pushed the application on the cloud. And then I just added this on the table, this data, and then you can see it when you access this URL. This was just for demonstration purpose in terms of saying, how do you deploy your database, your application, right, including your database on cloud. And then as you can see, those benefits of the cloud, faster provisioning, the flexibility, reliability, and all this. That's why most of the people, they decide to use a cloud. Is there any one of you tried to access it? Did you manage to access it? Friends? Yes, no? On the chat. Yeah, exactly. So, although I think it was it was quick, but I think if maybe you will follow this recording, right, you will able to see what we tried to do here. So I think cloud is a way to go. Hence, we try to incorporate it in all of our sessions that we are going to do. For example, as you can just see here, the next session will go on cybersecurity. We'll also just touch on it to say how security on cloud, for example, things like that. We're going to talk about data science. We're going to have a business intelligence and a blockchain around this. We'll see if this time will be allowing us to have that session, right? But maybe let's give you an opportunity from your side so that the link is there. I shared the link, the link is on top there. This is the link. Oh, actually, I must do to everyone, right? Sorry, my mistake, right? I think it seems like I was not sharing to everyone. Oh, that is the link. I shared the link to everyone. Then you can able to access. If you just click on this link, it should take you here. Sorry, Mababa. Yeah, I'm not sure if you wanted to say something.
No, Mutlago, thank you very much. I think unless if there are questions, I mean, what we saw today, we just to wrap up, we discussed the basic principles. I think the most important thing is that people, when we live here, we should just go and do more research and familiarize ourselves with more of these principles. And then, I mean, we shouldn't be afraid. I mean, writing code, when you see it for the first time, it's overwhelming for the new guys who are starting off. But as soon as you get the gesture to you get into the zone, then it becomes easier with time. So you shouldn't be overwhelmed when you start off, because I mean I imagine that if there's anyone who's new to programming here, they might be feeling, you know what, he showed us this thing called code and then he quickly deployed it to Azure and all that. But essentially this is very basic stuff, and then there's plenty and millions of online resources that you can read and watch videos for, and it should be able to assist you. And good luck with everything else that you guys have to do. Thank you, Mr.
Okay, great stuff. Colleagues, I think Mababa summed it very well. It's really about, today we just wanted to entice you in terms of how can you, I mean, the best ways of, designing and deploying or developing application, and how do you deploy it on the cloud, right? So I think if you have some questions, I believe most of you have the email that I've used to send you the invitation. You should let me know. And what then, I think there are a couple of questions. Let me see, okay. Is there a recording for last week's? Yes, so I will share with you the link for last week. It's already there on YouTube, so you should able to get it, Majimej. And add the certificates. Yeah, so the issue of certificate is for next year, right? We are having the thinking that you need to have a certificate of attendance at least, so that you can show that indeed you fairly understand, in this case, the basics around software design, the basic around accessing the cloud, how can you maybe deploy database and web services. So there's a plan around that, and then I believe next year we should be having a very solid plan in terms of how we are going to do this. Are we going to get internship after this bootcamp? Well, yeah. Well, look, so the intention of the bootcamp is that we just need to share with you some of these key technologies that are required out there. And then I do believe that indeed, if you, from your CV and whatnot, you're able to demonstrate that indeed you attended a session like this where you talked, where you saw, and even now you went and create the free account on these cloud platforms for you to practice, I believe that will really position you a lot. And then, of course, that is our medium to long-term vision, where that we think that this bootcamp must build a partnership with the being government and private or anyone else who might be interested to help you colleagues with the type of internships, because indeed we are looking for environment where we can practice this thing so that we are equipped for the future. Yes, the question and my answer I think here is that's really our wish and then our long-term vision regarding this, right? Maybe other thing that I just wanted to touch on is, as you can see here, right, I'm sharing Oracle one. So my aim is that you should be Googling this thing. Just go to Google and then say AWS, for example. That's the other thing I wanted just to say. AWS free account, right? If you come here, just go there, they will give you free credits so that you just log in so that you can able to practice this thing. You can say Google here. Google Cloud, right? Google Cloud free. You register, you are going to get the credits for you to do it. Being where I am now, Microsoft one, free, whatever, right? So I'm encouraging you to go and register here. When you register the first time, you are going to get credits. And then more so if you're a student, then you are also going to be given some credits for you to use. So this is a very key skill. I believe majority of us, we know. If you Google on everywhere, LinkedIn, anywhere else, you will see that the cloud is the way to go. It's the foundation of all these technologies that we are going to talk about. So my ask to you is, please make time, Google, register, get into this thing, and then do this thing. Just play around this, right? And then you create, you delete, because if you do not delete, you are going to consume the amount. Also, I also just want to, for the last one, is that just ensure that you are on the free tier, because if you are not, you'll be charged, right? So for now, my view is that get the student one if you're a student. If you are not, and then just create. The first time you create the account, you're going to be given free credits, and then you use those credits to navigate through this environment, right? So you can see this is my my subscription. As I mentioned, this is my subscription. It's going to, show you your spend, right? So you can see at the moment I already spent $15. What you can also do is you come to your cost analysis. It will give you the full picture of how you used your environment, which service consumed lots of your fund and things like that, right? And then these are the core real stuff that are happening out there. So I'm really appealing to you that create your environment, play around this thing. There are quite lots of things that you can do on this, right? And another important thing I wanted to mention is that if maybe you are using your own money, right? You can come and create the alerts to saying, I want to keep, in my case, I wanted to keep my alert, my budget to $10 per month, right? So what you do is you just come here, then create those alerts so that you want to make sure that you don't want to pass particular budget, for example, right? And anything that you do, after you are done with everything, if you create your asset, like what, and then this is what I'm going to do also. If you create your resources, right? When you are done with whatever you want to do, then you might just delete those. Because if you do not delete them, right, you are going to spend money on them. I think that's really the key thing. That's really the key thing that we colleagues need to be aware of, right? And then you can see, I'll just repeat what I just said now in conclusion now. There's quite a lot of things that you can do here. There's a compute, there's a network, there's a storage, and then other thing is I wish to challenge you colleagues that to do this and then try to get some certifications, right? There are quite lots of certifications that are out there. Google Cloud certification, you can mention, you can do it here. And then there are just quite lots of things that you can really do on this thing. So I really want or wish you to go and do these things, right? And then perhaps maybe one other thing I'm planning of doing is we just need to have a session where we're going to talk about the cloud alone, because I think now we're talking cloud with database and whatnot, but then with the concept of the whole cloud. What is cloud, so that all of us can be interested? So I'm going to ask you that for those who are interested, just send me an email so that just to gauge the interest of how many of us are interested with that session, so that we can have a session that purely talks to the issue around the cloud computing. Because as I said, cloud computing is the future. Cloud computing is the foundation of all this nice stuff we talk about, being Internet of Things, big data, and all that. Why? Because of these reasons that we've talked about, these reasons here, right? It gives us agility, scalability, flexibility, mobility, and reliability. So that being said, thank you very much, colleagues. I'm going to, can you please have your email? Yes, I think I said the email address there is what? It's the online bootcamp, right? I believe this is an email address. The email address that you got the invitation from, right? That is just use that email address, and then we should able to respond. We should able to respond today. Right? Any questions? Anything that from you colleagues before we can close? Next week we're going to talk about, as you can see on our website, right? Where is that? Next week, we're going to talk about cybersecurity, right? Choma will be joining us on that. This is a real schedule for us, right? Unfortunately, we're going to delete it now, but this is our real schedule, right? We're going to talk about cybersecurity. We're going to talk about data science, the other following, the business intelligence, and this. And then if you can see the commonality around this is cloud computing and the data across all of this. So which are the very key for us, more especially as students. We need to familiarize ourselves with this so that during our internship programs or interviews and whatnot, we should be in a position to be talking about this, even maybe at the basic level, because I think that's what really the market is looking out there, right? So let me stop here and then just find out the last word from any one of you, friends. All happiness, right? So now maybe last one.
Thank you very much, okay?
Thank you very much. So maybe other thing I want maybe people to talk about the YouTube one. Let me just go to YouTube and then I can share this our link here. Sorry, I can share this link, our session here. Maybe that is the that's the best thing for me to do, right? So you can see this is the last week one. Let me go here. Hey, how do I get? Okay, sorry, colleagues. What is this? But just go to the YouTube and then say online bootcamp with Mutlogo. Let me try this one. Link, copy link, address. Yes, this is the link for last week. I'm sharing it here. Just copy it here. That is the link, right? You can see that already. So this is the thing. I also just want to show you something here to say that your colleagues, your friends are using these things, right? You can see here even on the stats, right? People already spent 8 hours on this from last week. They're already having 62 views there. I'm just saying that there are people who are really using this thing because they know they are getting something out of this. And then we are available if you have a question. You can send me that email on that email address I've sent. And then as you can see also from last year, now I'm taking your time, right? So last year we have done this. We did talk about Excel. We talked about the database and all these things that we're going to talk about this year. There, you can just also Google there and find out some of the basic things that we did, because this year we take one level up where we integrate everything with the cloud, and also we are more practical, right? Unlike last year where we were just building the foundation. So these are the sessions that we talked about last year. If you want to get the basics around what is a blockchain, we're having that session in there. So just go to YouTube, say online bootcamp here, online bootcamp with Mutlogwe, and subscribe there. Then you should be in a position to see all of these things. If you are looking to know about the machine learning, we had a session in there. If you want to talk about the blockchain and then project management, software management, cybersecurity, go there to get the foundation of what are these areas all about, so that the next sessions, we should be knowing that you are having at least a rough idea of what you are looking for. I know we are having different audience here, students, those who need to change roles and all those things. So I believe that this environment is for us to use, is for us to benefit out of this. And then I'm hoping that in future, even us as an audience here, we need to have a platform where we should be talking to one another. For example, someone talks about internship, right? Some of you colleagues are here, you may be knowing some of, maybe having some networks and connections and all those things. So my idea also is that in future, we need to create a platform where we come and we meet together as a youth, but I'm not youth, I'm not including myself in that group, right? But as a youth of this country where you should be talking the real issues that will affect our careers, that will make this country a better country, even us as at the individual levels, right? So let's do that. Next week, we're talking about cybersecurity. If you have a question during the course of the week, let me know. I'm having the experts here in the industry. So that's what comforts me. We're having brothers and sisters who are willing to share their skills with us. And then therefore, we need to take advantage of this so that in the future, I should be inviting one of you guys, one of you colleagues to come and share with us what now you have learned out there. I think we are having very good network. We are building it nicely, but the key is that you should be using this service, these things, because to join this kind of 140 people who, access the cybersecurity, for example, right? What I like about our session is that it's a context-based, right? It's narrated by people who you are comfortable with, the people who you can easily get access to, people who I believe you can relate to them. We are more relatable, right? So I'm really asking you, colleagues, let's take this opportunity, this type of opportunity, to equip ourselves, because the future, as we said, the future is digital, right? And therefore, it's up to us. It's really up to us. We have this environment, and I'm quite excited that we have a plus 20 people attending today. So which means that we speak to the needs of our people out there. And then we really need to encourage you other friends out there to join us every Sunday. And then next year we'll be having every Sunday from February up until November, so that at the end of the day, Africa should be liberated. So I know I can talk the whole year. My other colleagues, they know me well here, but let me stop here. Thanks very much. Keep there, go to the YouTube, browse those things there. If you have a question, let us know. I think some of us, we have been there. We've been there for a few years. I think we have something to share with you, right? Being certification, being whatever else, reach out on that email address, then we'll take it from there. Keep well, ladies and gentlemen. God bless. Bye-bye.
Thank you, Mutabo.